Hi, I'm Stephen Downs. Welcome to another episode of Learning, Analytics, and the Duty of Care. Try that again. Ethics, Analytics. 3, 2, 1. Hi, I'm Stephen Downs. Welcome to another episode of Ethics, Analytics, and the Duty of Care. Today's video, part of Module 1, which is the introductory module to the course, is Ethics and Analytics. What do we mean by analytics? So, analytics generally is thought of to be related to data and related to decision making. For example, here, Picciano writing, it's thought of as the science of examining data to draw conclusions, and when used in decision making to present paths or courses of action. But this is by no means the only way of thinking about analytics. We can also think of it as the overall process of developing actionable insights through problem definition and the application of statistical models. That's what Cooper writes in 2012. The focus of this course is going to be learning analytics, that is to say, the application of analytics, which we'll continue to talk about here, in a learning or educational context. So, as applied to learning and education. And even looking at this definition, we can see there are different aspects of analytics that we can focus on, everything from data, environments, contexts, to the objectives of analytics and learning, the methods, and who is involved, or the stakeholders. When used in learning analytics is typically described in terms of its objective, which overall is to increase the chances of student success, but in a practical day-to-day sense might mean anything from basic reports and log data through experimentation and results of trials to the organization of students and faculty, to the transformation of an organization, the way it offers its classes, the way it presents materials, even through to a sectoral transformation. This model here is called the Maturity of Learning Analytics Deployment Model. But there's also what might be called a scientific goal to learning analytics. Looking more deeply at the subject, which is to say the learner, and trying to approach an understanding of how that person learns by studying the mechanisms of analytic systems in order to understand the mechanisms of human development and human cognition. There's this idea that these might work hand in hand to develop, shall we say, a science of learning. But generally, we want to do more than just understand. We want to optimize learning. We're looking to do what we're doing better. And so this involves, as George Siemens says, the measurement, collection, and analysis and reporting of data about learners and their contexts. In this course, I want to take analytics to mean something very broad. There are different ways of thinking about analytics, and it's easy to get distracted by focusing on a fairly narrow perspective. But let's look at some of the different questions we can ask. Gartner, for example, offers a model of analytics that moves from basic information management through to optimization. At the basic level, we ask what happened. Then we get a little more diagnostic and we ask why did it happen. Then we try to predict what will happen. And then finally, we look for efficacy or agency. How can we make it happen? Of course, the answers to these questions are going to depend a lot on who you ask. Typically, when we look at learning analytics, and by typically I mean generally or in the majority of studies that I've looked at or the majority of reports that I've looked at, the focus of learning analytics is described from an institutional perspective. And we read things like Slade and Tate here. Learning analytics offers the potential to provide educators with quantitative intelligence to make informed decisions about student learning. So they're used by the people who provide, organize, and present educational or learning opportunities. But what we mean by learning and education might be very different depending on who we're asking. For example, here we have an institutional leader saying it might be the case that we keep them, students, we retain them, but also we're able to provide them with better support. They're looking at it from this institutional point of view. The teacher might be saying, you can reflect on what works and what doesn't. What should I keep doing? What do I need to change? The student, meanwhile, is looking at analytics from a more personal perspective. I'm always curious about which areas I'm struggling in and which areas I am doing better in. These three domains are important to an understanding of analytics as a whole. Not only the institutional domain, sometimes called academic analytics, which looks at operational and financial decision making, student retention, topics like that. Not only teaching and pedagogy, learning design, curriculum, recommendation of materials, course paths, etc., but also learning from the learner's perspective, learning strategies, feedback, dashboards. All of these aspects of learning analytics play a role in the subject that we're talking about in this course. Another way of looking at the different types of learning analytics is to look at the different areas in which analytics is used. And we're going to see a similar tripart division of the field. The UC Berkeley Human Rights Center research team, for example, divides AI tools into three categories: learner-facing, teacher-facing, and system-facing, or institutionally facing. It should be clear, though, from our experience with the learning management system, that the same tool might face all three of these sectors at the same time. Just three ways of looking at the same data. In fact, as we look at it, as we look at the history and development of learning analytics over the years, there are numerous types, applications, and domains of analytics research in education. We can look at online systems, neural networks, students, paper learning, education, study, virtual learning, and more. All of these are different perspectives or different frames we can attach to learning. And in fact, as I prepared for this particular piece of work, looking for these frames, looking for these ways of characterizing analytics, I saw model after model after model, lens after lens after lens. There are many ways of categorizing and typifying learning analytics. None of them is probably best. For any given application, you could probably choose the one that fits your purpose most tightly. But if we're going to understand the subject of the ethics of learning analytics, we want to construe this as broadly as possible. The wider definition avoids the difficulties of trying to come up with a narrow definition, but also it makes sure that our look at the ethics of the subject is complete, that we're not ignoring potential ethical applications or ethical implications simply because the practice is outside the scope of learning analytics. Attempting to avoid that, if the question comes up, we'll include it as part of learning analytics, and then we'll sort it out from there. Now, analytics is part of artificial intelligence. Artificial intelligence has its own subdivisions and ways of breaking it down. This is a useful way of breaking it down. We can begin with artificial intelligence itself as a term, meaning something like building machines and software that can mimic intelligent behavior. Maybe mimic is the wrong word. A subset of that is machine learning, where instead of providing the AI with explicit instruction or explicit rules, we focus on giving computer systems the ability to learn from data without being explicitly programmed. And then a subset of machine learning is deep learning, which uses neural networks to, shall we say, learn a representation of a data set. And by neural networks here, what makes the deep learning deep is the idea that these neurons, these connected units, are organized in layers. And it's the layers that makes the learning deep. So it's a description of the topology of the network, and not, say, the idea that it can have deep thoughts or something like that. So we're going to take analytics broadly to include artificial intelligence. We're going to think of artificial intelligence broadly as software and possibly hardware systems designed by humans given a complex goal to act in a physical or digital dimension by perceiving their environment through data acquisition, interpreting the collected structured or unstructured data to reason or process that information and decide on the best action, where that action could be any of a number of things, including a prediction, including a categorization, including a representation, and more. We're not going to limit it to action as in action verbs. And we're going to keep the focus a wee bit narrow in the sense that we're going to focus much less on AI that's based on symbolic rules and much more on AI that's based on neural networks. In other words, machine learning and deep learning. And the practical reason for that is that most of the field has turned away from symbolic or rule-based systems. Now, there's a caveat there. And the caveat is that in many applications, you'll find a blended approach with a neural network being used and then rules being employed to apply constraints on those rules. We'll certainly consider such systems because such systems have ethical implications. If you apply or don't apply a rule, that clearly has an ethical implication. But we're not going to be thinking of the rules-based systems from, say, the 1970s and the 1980s as examples of current artificial intelligence or analytics. Now, generally through the course, I'm going to use the global terms analytics and AI, or artificial intelligence, interchangeably. When I say AI, I mean analytics. When I say analytics, I mean AI. When I use either term, I'm talking about learning analytics more specifically in general. We can think of these general uses as being fairly loose. When we need to be precise, we will be. So if we need to say machine learning as opposed to other methods, for example, as opposed to expert systems, we will. If we need to make the distinction between supervised and unsupervised learning, we will. If we need to make the distinction between convolutional neural networks, deep learning, etc., we will. But generally, when I'm using the global terms, they'll just be loosely applied. Finally, what makes this different? Why does the topics of analytics and artificial intelligence in learning create a range of ethical questions we haven't encountered before? Well, back in the 70s, Ware and all wrote that the dangers of digital technology stem from three major effects. And this pretty much captures a lot of it. First of all, there's scale. Computerization enables an organization, or today an individual, to enlarge their data processing capacity substantially. We look at the modern artificial intelligence systems, and they're looking at 1 billion data points. This is something that we just could not do in the, even 10 years ago, even 20 years ago. We just could not do that. Except, from the perspective of a human brain, which does do that. So, the things we can do with computers are, in that sense, different from the things that we could do with machines in the past. It's kind of like the difference between weapons and weapons of mass destruction. There's a significant difference between what you can do with the former and what you can do with the latter. Second thing that makes digital different is access. We talked earlier about the idea of context collapse, which is to say the case where something that you have written, perhaps intended for a specific audience, being available to a worldwide community, and then hearing back from that worldwide community, whether you want to or not. That's the sort of thing that digital technology enables. So people can access data much more freely and easily than they used to be able to. We read of a case where an analytics engine is generating faces by simply gathering thousands, millions of photographs of people on the internet and using those as input data. So this access is what makes this kind of AI possible. It's kind of the same thing for individuals. We now have access to things like Wikipedia and Google and Maps and more. And so we have at our fingertips masses of data that we never did before. And also, as we see, we have access to the technologies that allow us to process that data, to regard that data intelligently, and to draw inferences from it. We'll be looking at many examples of that. Finally, third, function. Computerization creates, as these authors, Ware et al. Said originally, a new class of record keepers. We now have a much better idea today than they did in the 70s what this new class of record keepers looks like. And it's not just companies like Equifax, which handle our credit data, or health companies, which handle our health data. It's companies like Facebook and Twitter that handle our messages back and forth to each other, which used to be secret, used to be private, used to be something that we did, except in the rare case of a wiretap, without anybody else looking in. Now, there's this class of companies that has custody over all of our interactions and all of our information. There's really no way to avoid that in a certain respect. And it's the creation of this new class of record keepers with corresponding power and responsibilities that creates a whole new class of ethical questions. So that overall is what we're looking at for analytics, artificial intelligence, learning analytics technology generally. We're looking at these different categories of machine algorithm, but we're looking at it as broadly as possible. And I hope I've given you a sense with this short descriptions of the varieties of different applications and systems that are out there. In the next section, in Module 2, we're going to focus specifically on applications of analytics in learning, applications of AI in learning. And we're going to use, to begin with, the characterization offered by McKinsey, looking at the questions that we're answering. We'll find that McKinsey's characterization falls short of what's actually happening in the field, and we're going to identify and classify a large range of potential applications. Now, the reason why we're doing this isn't to create some theory or model that best helps us classify and categorize applications of learning analytics. I know there's a lot of theories that do that, but that's not the point here. The point here is to capture a sense of what the benefits are that we obtain from the use of learning analytics. And it's important to keep in mind that these benefits are what generates this entire inquiry into ethics in the first place. If there were no benefits to the technology, then nobody would care. We simply wouldn't use it. But the fact is, there are benefits, and so our discussion of ethics is going to look at these benefits and look at the ethical issues in the light of these benefits. So we have the applications, we have the benefits, and we have the issues. And we're going to try to map those out. And even now, I have no idea what that map is going to look at. And a lot of this course consists of taking a lot of these entities, a lot of these things like applications and issues and ethical codes and so on, putting them in a chart and seeing what we see. And as we get to the later sections of the course, we'll get more of what my impressions are. But also importantly, you will be able to develop what your impressions are. And I'm sure they'll be different from mine. And that's the beauty of organizing a course this way. So that's it for this section of the course. There's one more video in Module 1 following this, which is the wrap-up discussion held on Friday. And then we'll take the weekend off, and we'll get back to it on Monday with Module 2. So thanks a lot. I'm Stephen Downs.